In this video, we've got a couple of fractions and we want to rationalize the denominator in both of these. Rationalize the denominator literally means to make the denominator rational, or to get rid of the radical sign. So we've got 1 over the square root of 7 and 1 over the cube root of 7. I'm going to write this index, that's the number that's in there, in that little crutch there, in the V of the radical sign. And that means the square root, the second root of 7. And over here is the third root of 7. So I'm going to work on these kind of simultaneously just because they're very similar. Okay, so in this first one, we want to multiply both the numerator and the denominator by something that would make the denominator have a perfect square under the radical. Over here, we're going to, in the second one, we're going to multiply by something so that we have a perfect cube under the radical because we're taking the cube root. So, back to the first one. To get a perfect square, well, this one is easy. If it's just the square root, then you just multiply by the square root of whatever is under there. Okay, square root of 7 in the numerator and the denominator, and that gives us the square root of 49, or the square root of 7 squared in the denominator. So let's write that out. We get the square root of 7 squared in the denominator. I could write 49 there, but square root of 7 squared. And then the square root of 7 in the numerator. Okay, so we can't simplify the numerator at all, but that's okay. We don't need to. We have the square root of 7. We just want to get rid of the radical in the denominator. Well, the square root of something squared is just that something. That's 7. So 7. So that's our answer, or our rationalized denominator in the first one. Now over here in the second one, we have an index of 3. So that is the cube root of 7. So we want to multiply by something that will give us a perfect cube under this radical. Well, we have 7 to the first here, so we are going to multiply by the third root of 7 squared. Then when we multiply those, we'll have 7 cubed under the radical. Now, of course, I've got to do that up in the numerator as well, the cube root of 7 squared. So let's write the result here. 1 times the cube root of 7 squared is just the cube root of 7 squared. And the cube root of 7 times the cube root of 7 squared is the cube root of 7 to the third. Now, just like back in this example, the square root of something squared is just that something. Well, the cube root of something cubed is just that something. So we're just going to have 7 in the denominator. So I'll write that first. 7 is in the denominator. That denominator is rationalized. And then up in the numerator, we can't simplify this, but that's not what we're worried about. We're okay having a radical in the numerator. And this is just notation. That's I don't know who made these rules, but this is what we're going to follow, that we can't have a radical in the denominator. So we have the cube root of 7 squared, or just the cube root of 49 in the numerator. So that is our rationalized denominator for both of these fractions. I hope that helps.